Yeah. So I want to welcome everyone to the APH 2024 National Coding Symposium. Today our focus is on student engagement of all levels. We hope to inspire you to recognize that coding is fun, challenging, and can be accessible for all. We hope that our dynamic blend of speakers with diverse experiences and presentations inspire or potentially change your perceptions of coding today. Our learning objectives for today are: 1, discover at least 3 resources for accessible coding programs. 2, identify both digital and tactile materials for students' use. And lastly, explore at least 2 accessible common programming languages taught in schools. Okay, now I think we're ready to get things started officially. So I'm going to turn things
Yes.
over to Leslie to do our introductions for our speakers and get us moving. Thank you.
Okay. Thank you, Jeff. Okay, very exciting. I'm very excited to be here. My great pleasure to go over our slate of presenters today. So when we took this new tact of putting a lot of effort into our days of code, into our hands-on student-focused events, we decided we still needed this symposium, this coming together of ideas and sharing. So we decided to focus in and do deeper dives and have 3 areas that seem to be some of the biggest concerns at the time. And please always give us feedback as to know what you are looking for to have more information on. So we're going to start out with some uh, online learning to code platform with the Hour of Code, and really focused in on data science and using accessible charts and graphs. Big deal. We will follow that with some really, really cool robotics, and you'll be able to walk away with some sample code to play with on your own. We'll have a short break, and we will finish out the day with some unplugged ideas, tangible bridges in the accessibility gap in the classroom. So with that, I would like to introduce our first speakers. We've got a great team, some familiar faces and some new faces. We have Dr. Andrea Stefik, Dr. Alex Hoffman, and Tim Kuthi to talk about data science.
All right. Hello, Dr. Andrea Stefik, or everyone calls me Stefik. Can you hear me okay, Leslie?
Yes, you're good.
All right. Well, thank you for the intro for the 3 of us, and I'll hand it off to my colleagues in a moment. But what we're going to talk about today is an hour of code in a programming language that is called Quorum, specifically related to data science. And um, so first of all, if you're unfamiliar with computer science in general, there's a gazillion programming languages. That's not an exact number, but it's true. Part of the reason why that's the case is that it was never standardized across the field, unfortunately. So programming languages kind of do whatever you want. If you're unfamiliar with the debate, not only is there no standard, but there's also very little or no evidence about what the impact is on different kinds of people, which is in many ways one reason why I think it wasn't just that there was no evidence on people, there was no evidence on people with disabilities or women or all sorts of things. And I think over the last 10, 15 years, people have been trying to fix that. So the particular language that I helped invent is called Quorum. Um, you can invent whatever you want with it. It's a programming language, which means you can invent anything you can imagine. But we call this evidence-based programming, and all it really means is that the language changes based on data. So we do studies with human beings, and we ask them, we say, hey, does this stink? And they say, yes, it does. And we say, okay, well, what should we change? And then we make adjustments over time. But part of Quorum is we've been also trying to tackle deep challenges in accessibility. So my favorite has been the accessible graphics problem, which is basically that if you are using screen readers, they generally don't talk to hardware accelerated graphic systems like 2D and 3D displays. But we've solved these problems in many ways, and they're now built into Quorum. So even if you can't see the screen, if you want to build your own 3D games, you're good to go. But past that, we make steady advances on all sorts of things related to accessibility. It's one of our primary missions. So the most recent thing, which literally came out last night, is that we've added support for Lego spike robotics. So if you have a student team and you want to do Lego spike kits in one of the competitions or something, you can download Quorum as of yesterday at about 4:30 p.m. and you're good to go. You can now go participate in these competitions. In terms of cost, it costs nothing. You can do with it whatever you want for whatever you want. It's a programming language. Most programming languages are free, and ours is no exception. We're fortunate enough to be funded by universities and the National Science Foundation and other areas. Whoops. Past this, we're going to be talking about data science, and data science is a funny thing. Oh wait, I'm jumping into Alex's spot. Alex, go ahead. Take it away.
All right, Stefik, make a funny face if you can hear me. Ah, yeah, perfect. Great funny face. All right, everybody. So my name is Dr. Alex Hoffman. I teach data analytics at Belmont University. And data analytics is really just the businessy term for data science. So data science is really what you're doing is you're taking a little bit of statistics, and you're taking a little bit of programming, and you're putting them together and making a baby called data science. It's really just taking a whole bunch of data and numbers just to learn about or investigate something. So you take this data, you take this programming, and you're creating something. Often you're making different types of visualizations, you're getting different types of results out of that to come to some sort of conclusion about your data. So data science is really used in almost every industry these days, from e-commerce or business, finance, healthcare. It runs the spectrum of pretty much everything. And so all companies are looking for data scientists to figure out what it is that they can do with the information that they're getting. We've had so much data created over the last decade that it outweighs all the data created before that throughout the history of time. And it's only getting bigger every single year and even every single day. We're getting more and more data. And so we're trying to figure out what is it that we can do with this data? What can we learn? And how can we really impact people's lives? And that really makes it it's hard to understand because, there's some math behind it. It's hard to understand because there's so much of it, and the programming as well. And so they're having to put together a lot of different domains to really figure out what it is, and how do we deal with all of these numbers. Okay, so next slide, please. All right, so we've taken a lot of steps together as a team to figure out how do we handle accessible data science. And there are multiple different ways that we've done this. So Stefik and team have invented Quorum blocks. So this is a block-based version of Quorum that we'll see a little bit more of in just a couple of minutes. But that is one of the steps to make it accessible data science a little bit easier. Also trying to make the code more human friendly. So programming itself has come a long way since Ada Lovelace and Charles Babbage in the 1800s, or even just the 1950s when we had like computer programming. Programming has come a long way to be more approachable to everybody, but that doesn't mean that it was always accessible. And so with Quorum blocks, the whole intent was to make programming approachable by everyone, but also accessible to everyone. And especially one of the difficulties that Stefik and team really figured out was how to make charts accessible to everyone as well. So moving forward, we're going to talk about Quorum blocks, which is the next slide. So we're going to talk about Quorum blocks here coming up. So really, what is block-based programming? Well, think of it as Legos. You have a set of Lego blocks, and you're trying to build those all together. So these blocks help you to visualize code, and how to understand how coding works. So they're really just building these blocks together and visualizing the scope of the blocks. So scope being, contained inside of each other, and building them together, scaffolding together a programming language that is visual. Now, when you're visualizing these scope, or when you're visualizing these programming languages, there is a difficulty in making a visualization accessible as well. And so that was a big challenge that Stefik and team really had to address in there, is how to make a visual programming language accessible to everyone. Now, just coming back to block-based programming languages in general, the research literature has shown that block-based programming helps with the transfer of learning, specifically in a specific range of when people are learning how to program. But as I was saying, it's often unusable for people with disabilities. So the making it accessible has been a huge challenge that Stefik and team have been working on for a while now. Now, with block-based programming languages, while you can scaffold that language and it helps with the initial stages of learning and even learning transference, it's really primarily just been used in K-12 and only for a limited term. And so people will transfer that learning into text-based languages fairly quickly. Yeah, next slide. Thanks. All right, so this is a view of Quorum blocks, and on the screen there is a screenshot of it. On the left-hand side, I'm just going to talk about the image just for a second here. So on the far left-hand side of the image, we have different categories of blocks. And then to the right of that, there is a pane, and the pane is talking about the camera class. There's a filter just below that where you can filter for certain actions inside of the camera class. And we have a listing of the variables inside the camera class. And as I was just saying, the actions for the camera class are just below that. Now, these actions are different kind of blocks that can be dragged into the programming pane. And so there are just a couple examples we have here are the cam2d for compare and for equals. So those are two different blocks, compare and equals, that could be dragged into the programming pane. And then on the right side of the screen, we have the programming pane that has multiple different blocks in there. So we have an if block that is nested inside of two other blocks here. And inside that if block, we have some programming going on for getting the camera in 2D and getting the camera in 3D. So this screenshot is just an example of some programming that can be done. And this is a little bit more complex than what you would start out in your very first time programming. The point here is that these blocks can be nested together, but it's also Quorum. The Quorum blocks themselves were born accessible. So Quorum was an accessible language from the beginning, and it was created that way. And then when Stefik and team decided to go towards creating a block-based language to make it more approachable, the goal was also to make it accessible for everyone. Stefik just mentioned a minute ago that it is now available as of this month. So they spent a lot of time, did a really great job making Quorum, not only an offline with an IDE or an integrated development environment, they also made it available directly online. And so that way you can go to the Quorum website and just be able to start programming and experimenting directly online. So all of the existing Quorum code, whether you want to do data science or maybe you want to do robotics or even creating games, can all be in blocks and block-based programming. And you'll be able to switch back and forth in between there. And for most of this, you'll be able to do it just completely and directly online. So it's a really powerful system that Stefik and his team have spent a lot of time and a lot of hard work creating it. And so I'm going to hand it now back to Stefik, who will continue on.
Okay, thanks, Alex. And I should say too, Alex keeps saying Stefik and team, but of course he was on that team for the longest time until he finished that pesky dissertation, which of course influenced the design of the blocks quite significantly. So, but anyway, so one of the challenges with coding, as I imagine a lot of teachers, especially for those of you that are teachers in the audience, kind of realize is that kids are at different levels. And I see in the chat too, there was someone saying, oh, that this might not be at my kid's level, but the reality is that coding is at all sorts of levels. And you can do coding when you become a professional, but actually many programming languages, you can knock it down to bite-sized chunks for kids to learn. Just as a quick example, in my own home state of Nevada, it's actually required by law under this law called SB 200 that kids start learning programming in kindergarten, which is very unusual. All kids, with or without disabilities, men, women, whatever. And what's fascinating about it is, how do you make programming kindergarten friendly? That's a pretty significant challenge, right? So actually, that brings up this question for something like data science. I'm going to show on the screen, and I'm going to kind of read it out loud a little bit, what traditional data science might sound like or look like if you can see the screen. And to say that it's esoteric is being very nice, right? Like, to say that it is weird is being very nice. To say that it's kind of nuts is maybe even still too generous, right? So let me kind of read it out loud. Again, this is not Quorum, this is R. Data equals read.csv left paren double quote data slash results 2023.csv double quote comma header equals true comma strings s factors equals true right paren data dollar normalized underscore response less than dash left paren data dollar response slash data dollar max right paren, and it just gets worse. And it uses weird terms. AOV. What does AOV mean? Well, unless you just not only know statistics, which is college level already, but unless you also know mathematical modeling, which is a certain subset of college classes, and then on top of it, you also have memorized the weird words that are used in specifically this specific programming language, it gets really strange. So you get words like Bonferroni, or paired t-test, or p-adjust method, or pairwise t-test. Strange things. And one of the questions that we had in the lab is, although it's an area like stats may not be possible to make, or data science may not be possible to make 100% kid-friendly, you can do better, we suspect. So one of the things that we've been experimenting with, and we have a new academic paper that Tim Cluthy on this call just finished publishing, it must have been, I don't know, a month ago or something, that we've kind of nicknamed Say What You Do. And so one of the strategies that they used for the longest time in data science and statistics, and I don't know why, like, it doesn't make any sense to me that this would be the strategy, but it was that name everything either with single letter variable names like T, P, F, whatever, which makes no sense to humans, or name it after old dead white mathematicians, which I just find really odd, right? So an example might be, you might name something Kruskal-Wallis, but it really just means compare the means of some rankings. Or you might have a name like ANOVA, but it really just means see if the averages are different. And when you think about it, a kid can do averages in probably like middle school or maybe upper elementary school. But if it's not written in a way that kids can understand, then it might be very difficult for them. So we use a series of strategies, and we've run empirical studies to try to see, how do we make this make sense for people that really need to understand data or understand what's going on in the world when drugs or other things are approved, but they want it written kind of at their level so that they can figure out what it actually means in a meaningful way. So here's an example, and on the screen it's visual, but I'll kind of give the rough things. Instead of saying AOV, you might say compare means. Instead of saying having it output esoteric numbers like P and C, what you would do instead is you'd ask it for a summary, and it'll put that at the 8th grade reading level or the 7th grade reading level or whatever is that we decided. I think it was 8th. The idea being we try to put the code into a way that's not necessarily trivial to understand. Data science is a little bit harder than some areas of coding. I think teachers that have worked with Quorum or stuff like that often might use robotics or other things at the very low levels. But by the time you're hitting like middle or high school, things like data science are part of your classes anyway, and they should be understandable by people in those ages. And then finally, one of the big challenges with data science is actually the visualization. If you aren't familiar with data science, or you're not such a masochist that you read academic papers for fun, which would be pretty normal, charts become a really challenging problem. And Amber, yes, they'll pass around the slides, and we'll make sure they're available too. One of the challenges is that in standards like what's called WCAG, or basically national standards for adjusting accessibility, part of the challenge is that the best you really have is alternate description. And it basically forces a human to decide what the chart means. And the problem is, it doesn't matter how much data you have. You could have a near infinite amount of data, but you get one alternate description. There's guidelines for it. One of them is called the National Center for Accessible Media. They've got some guidelines, and they're fine. But as far as we can tell, they really only give you something meaningful for really tiny charts. But the problem is, data science has to work for anybody. And on top of that, there's a study by Jeff Bigham and others basically showing that nearly 40%, at least in their data set, which you need data science to analyze, we're missing alternate descriptions anyway from the things that they looked at. In other words, not only does alternate description not really work that well, but on top of that, people don't do it anyway. And so it becomes a question of, well, how do you maybe automate or improve this situation? So we have a technique that I kind of jokingly on the slide, we put that they're automagically accessible. But the idea is pretty simple. Is that we use the same stuff that's built into Quorum, the math and the statistics kind of stuff. And when we generate a chart, it doesn't make one alternate description. It generates structure around the chart. It puts it in a way that the web can understand and that screen readers can understand, and it's visual. The basic idea is almost kind of like generating thousands of alternate descriptions, but then allowing the user to go between them so that they can get meaningful information with no human intervention. So a human doesn't write these. In fact, I don't think a human would be able to write these very well because they're quite challenging to do. A computer automates it. So I'll give you an example. If you have a chart, it might tell you what's in the chart, what kind of chart it is, what kinds of things are there. If you have a bar chart, it might give you summary statistics about it. It might give you something written in English to try to tell you what it is. It might let you traverse the bars so that you can see what each bar is and what its label is. It might tell you information about the axes. And that's the thing. If you want all that in a single alternate description, it'd be very long. But if you allow the computer to figure out how the accessibility should be calculated, you can do much, much better. And we've been working on studies to try to find the pros and cons with these kinds of techniques. So far, though, they work pretty well. Okay, so at this point, I'm going to hand this off to Tim Cluthy, who is a PhD student at UNLV, and he has put a link into the chat for a demo of an online version of Hour of Code. Now, the purpose of this for an Hour of Code is that it's designed to be for much younger students than the kind of stuff that even I showed on this slide. So I'll let Tim take it away, and then I will shut my mouth. So thank you.
Okay. I am Tim Cluthy. I work with the Quorum team. I'm a graduate student, and Dr. Stefik is my advisor. And this is some of the stuff that I've been working on the last few years with him and the team while I'm pursuing the PhD. So this is our Data Science Hour of Code. And what we've done is we've taken what you might find in Form Studio and tried to package all the data science stuff together and make it in more of a portable format where you can just open up your browser, get on here and try it out without having to download a bunch of stuff. I'm going to get my screen reader turned on.
Taskbar.
Okay, can you guys hear my screen reader now?
Data Science
I see
Hour
a
of
thumbs
Code
up.
Activity 1 bar Quorum.
Yes.
From NV, show speech, active data science hour.
Okay, sorry. So first, I'm just going to give you kind of the overall idea of what we're doing in this hour of code. Basically, we are data scientists, and we are going to be working with a group of researchers from Antarctica. Those researchers have been collecting a bunch of data about penguins in their area, but they need some help answering questions about them.
New notification from Discord, comma.
So our job is going to be to make some charts from this data and answer some of those questions. So before we get started on the lesson, I'm just going to give a quick overview of the page. And actually, I think Stefik mentioned it. I did drop a link to this. So if you want to go to that link and kind of follow along at your own pace as well, that's perfectly fine. Or if you'd rather just kind of watch me and listen, and I'll talk through everything and kind of give an idea of what we're doing. So on this page, it's broken down into a few sections. We have the scenario, which is what I kind of covered, that's just brought across all of our lessons.
Data science hour of scenario colon, introduction colon.
We've got an introduction, which kind of gives an idea of what's going on in the current lesson.
Instructions colon, heading level 2.
We have instructions for the current lesson. So this is going to be the specific things that you're going to want to do in the code editor to be able to answer the questions below.
Coding colon, heading level 2.
We've got the coding section. This is where you'll find our block code editor.
Blocks heading level 1, activity colon, heading level 2.
And finally, we've got the activity, which includes a few questions where you'll actually type in some answers and submit them. So moving back up to the top.
Dialog sites you visit. Data science, blocks heading level 1. Coding, instructions, introduction colon, heading level 2.
Okay, so for this lesson, it's activity 1, displaying a chart. When you're working with data science, usually you've got some data set that you're trying to discover some information about. And if it's a very small data set, it might be easy enough to just open it up in a spreadsheet and look through a few numbers in a table. But as data sets get larger and larger, it gets a little bit easier if you can aggregate that data and have something help get the information out of it rather than going piece by piece. So we've got this data set called penguins1.csv. And below this, I've got a few rows of that data set available just to
Next
get an idea of
tutorial.
what we're working with. In this, we've got 2 columns. We have bill depth and bill length. And both of these have numeric values. So for bill depth, we have numbers like 18.7, 18.3. And for bill length, we have numbers like 39.1 and 37.8. So this would be the sort of the length of the bill of a penguin, so how long it is, or the height of a bill, so from top to bottom. Next, we'll move into the instructions for this lesson.
Instructions colon, heading level 2.
So for our instructions, we're given 4 items. We need to use the blocks in the palette on the left. Then we need to place the chart display block below the chart show legend false block at the bottom of the block editor on the right. Then we need to run the program. And then finally, we need to use the chart in the canvas to answer the questions in the activity section. So I'm going to move down to our code editor and kind of give an idea of what we're working with down there.
Navigation landmark list, data science, scenario, introduction, instruction, coding colon, heading level 2, hide palette button.
Okay, so now we are on our code editor. At the top of our code editor, we have a few buttons that we can use. We can hide the palette.
Zoom in button.
We can zoom in.
Zoom out button.
We can zoom out.
Hotkeys button.
There's a hotkeys, which will bring up a dialog with some of the extra hotkeys you can use while you're working in the code editor.
Full screen button.
There's a full screen button if you want to get a larger view. I will actually activate that.
Hide palette, zoom out, hotkeys button, full screen button, run program button.
Next, we have a run button. This will make our program run.
Enter block editor button.
And finally, we have the Enter Block Editor button.
Amanda Rada has joined the meeting alert.
So now that we're on the Enter Block Editor button, I'm going to press Enter to activate it.
Block editor dialog. Palette comma. To navigate to the palette, press Enter dot. To navigate to the editor, use the arrow keys dot. To navigate back to here from the palette, press Shift plus Enter dot comma.
Okay, so now we are focused on our block editor. The block editor is broken into two pieces. On the left-hand side, we have what we call the palette, which contains some of the blocks that we want to use in this lesson. And on the right side is the code editor, which contains our entire program. So it's a set of blocks that we'll use to create our chart, but currently it is incomplete. Currently, we are focused on a navigation node that lets you jump between the palette and the block editor. So I will have it repeat.
Block, palette comma. To navigate to the palette, press Enter dot. To navigate to the editor, use the arrow keys dot. To navigate back to here from the palette, press Shift plus Enter dot comma.
So currently we are looking over the palette and we are able to press Enter and it will focus us down into the palette. Or we can navigate to the editor using the arrow keys. We can navigate back to here from the palette by pressing Shift plus Enter. So I'm going to press the right arrow key.
Block editor comma. To navigate to the editor, press Enter dot. To navigate to the palette, use the arrow keys dot. To navigate back to here from the editor, press Shift plus Enter dot comma.
And now we're focused over the block editor, and it's got the same set of instructions. We can press Enter to go into the block editor. We can use the arrow keys to move between it and the palette. And we can press Shift Enter while we're in the block editor to return to this navigation section. So our first step that we need to do for this lesson was to go to the palette on the left and get the chart display block. So I'm going to press left to get back to the palette.
Palette comma. To navigate to the palette, press Enter dot.
And then from here, I'm able to press Enter and it will focus down into the palette section.
Display a chart label. Block editor. Display a chart label. Heading level 2 navigation menu comma. Landmark 1.
And something that you may have to do is force your screen reader into focus mode. Currently it's in browse mode because it's finding some of the text elements for the web page. But if I press Insert space, it should now be in focus mode.
Chart colon display left paren, right, display a chart label.
So as I enter, it should say display a chart label. This is the label for the current set of blocks that are in my palette. And if I press Tab,
Chart colon display left paren, right paren, comma, button.
it should now be focused on a block inside of our palette that says chart display, and it's a button that we can activate. So now if I press Enter,
Chart colon display left paren, right paren, comma, block.
now what we have is what we call a placeholder block, which is that palette block that we pressed Enter on is now on the right side of the code editor inside of our set of blocks. And we can move it up and down with the arrow keys to find the place we want to drop it. So I'm going to press down once.
Use libraries.interface.controls.charts.scatterplot, comma, block.
And as I move down, it's going to tell me the block that is just above it. So I can try and find the spot in the code that I want to place it. I'm going to press down again.
Blank, comma, block. Data frame, comma, block.
Pressing down some more.
Frame colon load left paren, quote data slash penguins1.csv quote right paren, comma, block.
And from the instructions, we're looking for the chart show legend false block. So I'm going to continue pressing down.
Frame colon select all columns left paren, right paren, comma, block. Scatter plot chart equals frame colon scatter plot left paren, right paren, comma, block.
Then down one more time.
Chart colon show legend left paren, false right paren, comma, block.
Okay, so that was the chart show legend false block. And I want to place this chart display block just below it. So I'm going to press enter.
Chart : show legend left paren, false right paren, comma, block.
So now that I've pressed enter again, I've placed the placeholder block into our set of code. And I can kind of give a brief idea of what this program's doing from top to bottom. We have on lines 1 and 2, use libraries, compute statistics data frame, then use libraries, interface, controls, charts, scatterplot. This is where we're importing some of the libraries that we'll need to use. Then on line 4, we make our data frame by saying data frame frame. On line 5, we load in our data set with frame load, and then in quotes, data/penguins1.csv, end quote. On line 6, we select all of the columns on the frame. On line 7, we create a scatterplot chart by setting it equal to frame:scatterplot. This is where it takes those selected columns and creates our scatterplot object. Next, for that object, we say on line 8, chart show legend false, because we want to hide the legend. And finally, the block that we placed in, we have chart display, which is what tells the compiler that you want to actually show the chart to the screen. Now, when you're going through this lesson, you don't need to know what each of these lines of code actually does. I just want to give kind of an idea of what the full program does, but really you're just interacting with those few palette blocks and placing them in the correct location. So now that I've got my full program on the right side in my code editor, I want to run the program. So I'm going to press escape to get out of the block editor.
Button enter block editor.
And now I'm focused back on that enter block editor button. And I'm going to press shift tab to move back to the run button.
Run program button.
And now I'm going to press enter.
Build successful. Console output.
Okay, so it built successfully, and I need to focus on the canvas where it is now running. So I'm going to press tab.
Stop program button.
And then tab again.
Enter game button.
And this is where we can enter our game and take a look at the chart.
Game dialog. Scatterplot, comma, with 1 series and 333 points, comma, overall minimum x 13.1, comma, overall maximum x 21.5, comma, overall minimum y 32.1, comma, overall maximum y 59.6. Dot. To navigate the chart, comma, use enter to move into the list of points or use the arrow keys to navigate the chart information. Dot.
Okay, so right when you get into the chart, it tries to provide you with some of that basic information about the whole summary of the chart. First, it said scatter plot. It said we have 1 series with 333 points. And then it listed out some of the overall minimum and maximum values for X and Y. And then it gave us some instructional text. To navigate the chart, use enter to move into the list of points, or use the arrow keys to navigate the chart information. So before I dive into the points, I want to kind of get an idea of what's going on with our chart. So I'm going to use the arrow keys to move around the chart information. Pressing the right arrow.
X-axis, comma, shows bill line depth and ranges from 13.1 to 22.1. Dot.
Okay, so this is the x-axis, and it's showing bill depth, and it ranges from 13.1 to 22.1. Going to press right again.
Y-axis, comma, shows bill line length and ranges from 30 to 65. Dot.
Okay, so this is the y-axis, and it's showing the bill length with a range from 30 to 65. And then if I press right one more time.
Scatterplot, comma, with 1 series and 333 points, comma, overall minimum x 13.1.
It circled us back, and now we're on that main summary node. From here, we can also press enter, and it will take us down to the list of points. I'm going to press enter.
From Kimberly Ford to all panelists, left paren, 13.1, comma, 42.9 right paren, comma, 1 of 333 points. Dot. To navigate the list of points, comma, use the arrow keys to move between points in value order on the x-axis, use page up or page down to move between points by value order on the y-axis, use shift plus enter to return to the series list. Graphic.
Okay, so that was a lot of information. Currently, we're focused on the first point in the full list of 333 points. The first thing it says as soon as you get to the point is it tells you the actual coordinates. This one is at 13.1, 42.9.
From Victoria Sanders to everyone.
And then when you first enter any of the lists, it tries to give you some information about how to navigate that specific list. In this case,
From
on the
Stephen
list
to
of
everyone,
points, we can use the arrow keys to move between points in value order on the x-axis, or we can use page up or page down to move between points by value order on the y-axis. So we've got two directions we can move between the points. And finally, we can use shift plus enter to move back up into the series list, which is where we were with the chart information. So I'm going to just move through a few of these points, but then we'll get over to the questions so we can start completing the assignment. So I'm going to press right.
Left paren, 13.2, 46.1 right paren, comma, 2 of 333 points. Graphic, from Stefik to everyone, yes there.
And I'm going to press right again.
Left paren, 13.3, 44.9 right paren, comma, 3 of 333 points. Graphic.
So every single visual element that's on the chart is accessible. You can get to it, and it already has a label and a description provided for it automatically by the system. I won't make us go through all 333 points though, because that'd be quite a bit.
From Kimberly
So
Ford to all.
I'm going to press escape to get out of our game.
Button enter game.
I'm going to minimize our block editor so I can go find our questions by pressing Shift Tab until I find the minimize button.
Stop program button. Full screen button.
Okay, I'm going to press Enter. And now we're out of full screen. And I'm going to go down to our activity section.
Main landmark data science hour of scenario : introduction, instructions : coding : blocks heading level, activity : from Kyra Mays to everyone.
Okay, so now I'm in the activity section, and I'm going to tab through and look for the questions.
From Marguerite Ombedikau to main landmark, 1. What tick is the largest bill length question? Spin button editable blank.
Okay, so our first question is, what's the largest bill length? I'm going to go back up to our game so we can go
From
inspect this
to
chart.
everyone. Console output grouping build successful. Enter game button.
I now have the enter game button focused, and I'm going to press enter.
Game dialog. Scatter plot, with 1 series and 333 points,
And as I come into this chart, I should be focused on that third point still. I'm going to press Shift Enter to move up to the chart information.
Scatter plot, with 1 series and 333 points, overall minimum x 13.1, overall maximum x 21.5, overall minimum y 32.1, overall maximum y 59.6. To navigate the chart, use enter to move into the list of points or use.
Okay, so I want the largest bill length, and the summary tells me the minimum and the maximum value for each axis, but I need to remember which of these axes is actually the bill length. So I'm going to press the right arrow key.
X-axis, shows bill line. From Alex Hoffman to all.
I'm going to have it repeat that.
X-axis, shows bill line depth and ranges from 13.1 to 22.1.
Okay, so my x-axis shows bill depth. I'm going to press right again.
Y-axis, shows bill line length and ranges from 30 to 65.
So my y-axis shows the bill length. So I know that I'm looking for the values on the y-axis, and I want to find the largest value. So I'm going to go back to our summary.
Scatter plot, with 1 series and 333 points, overall minimum x 13.1, overall maximum x 21.5, comma, overall minimum y 32.1, comma, overall maximum y 59.6 dot.
Okay, so our overall maximum y value was 59.6, so that should be the answer to our question. I'm going to press escape to get out of the game,
Button enter game.
and then I'm going to tab down to our question.
Console output grouping build success. 1 dot. What tick S the largest bill length question? Spin button editable blank.
I'm going to submit our
9
answer.
dot. 6. 2 dot. Submit answers button. 1 of 2 correct dot. Please enter an answer dot. Correct dot.
Okay, so 1 of 2 is now correct. We have successfully found our largest bill length. Next, we need to see what question 2 is asking us. I'm going to shift tab back.
2 dot. What tick S the largest bill depth question? Spin button invalid entry.
Okay, so we're looking for the largest bill depth. Going to move back to our game, and it's going to be on the x-axis.
1 dot. Console output grouping builds. Enter game button. Game dialog. Scatter plot, comma, with 1 series and 333 points, comma, overall minimum x 13.1, comma, overall maximum x 21.5, comma, overall minimum y 32.1, comma, overall maximum y 59.6 dot.
Okay, so our overall maximum x is 21.5. Going to escape out of the game again
Button enter game.
and tab down to question 2.
Console output group 1 dot. 2 dot. What tick S the largest bill depth question? 2.
And I'm going to submit
1
our
dot.
answer.
5. Submit answers button. 2 of 2 correct dot. Correct dot.
Okay, we are at 2 of 2 correct, so we've found both of our answers for lesson 1. We can move back on to lesson 2 now.
Labeling it. Next tutorial link.
At the bottom
Next
of the
tutorial.
page, we have a link to the next tutorial.
Data Science Hour of Code Activity 2 bar Quorum Programming Language Document Busy blank. Data Science Hour of Code.
So in this lesson, we're going to be learning about labeling our chart. Some of the things on that previous chart that were a little bit default were, 1, the chart was named chart. It didn't have an actual name assigned to it. And the axes were named based on the actual header values. So you may have heard bill line length. That was it reading out the underscore that's used in the header name. So we're going to try and clean up our chart and make it a little more presentable. We might want to share this with a friend and maybe publish it somewhere, put it on a website. So what we're going to do in this is learn a little bit about customizing the chart title, the chart subtitle, and the axes titles. And we are going to be using that same file, penguins1.csv, and our instructions
in the code editor below.
For this task are to use the blocks in the palette on the left. Next, we're going to place the chart set title penguins block below the scatterplot chart equals frame scatterplot block in the block editor. Then we're going to place the chart set subtitle bill depth versus bill length block below the scatterplot chart equals frame scatterplot block in the block
From Aaron
editor.
Weaver to everyone :
Then we're going to place the chart set x-axis title bill depth block below the scatterplot chart block. And then place the chart set y-axis title bill length block below the scatterplot chart block. Finally, we're going to run the program and then answer a few questions in the activity section. So I'm going to move us back down to our code editor. Going to
navigation
tab.
landmark list with ref log commute log open join down main cut trying list with pen hide palette button.
Okay, so we're on the top buttons of our block editor, and I'm going to move through these.
Zoom in button.
Tabbing again.
Zoom out button. Hotkeys button.
Okay, so before we get into the editor, I want to go through some of these hotkeys because we might be moving through the the code editor and the palette quite a bit, and maybe there's an easier way we can do that than shift entering and moving through the navigation layer.
X button hotkey shortcuts heading level 6, list run program Alt plus Shift plus R stop program Alt plus Shift plus S hide palette Alt plus Shift plus X zoom in Alt plus zoom out Alt plus dash open. From Aaron Weaver to everyone :
I'm going to go through these one at a time.
out of list heading level 6 hotkey, list with 9 items run program Alt plus Shift plus R.
So on the Windows side and the Mac side, there are going to be slightly different modifiers for these keys. But if you are on Windows, you'll use Alt-Shift-R if you want to run the program.
Stop program Alt plus Shift plus S.
To stop the program, we can press Alt-Shift-S.
Hide palette Alt plus Shift plus X.
If we want a little more screen space for our code editor, we can hide the palette using Alt-Shift-X.
Zoom in Alt plus plus.
We can zoom in with Alt plus.
Zoom out Alt plus dash.
We can zoom out with Alt minus.
Open help Alt plus Shift plus H.
We can open this hotkey menu using Alt-Shift-H.
Navigate to palette Alt plus 1.
We can navigate to the palette using Alt plus 1.
Navigate to blocks Alt plus 2.
And finally, we can go to the blocks with Alt 2. So instead of having to do Shift-Enter to move up into navigation and then arrow keys to move between the different sides, we can just use Alt 1 and Alt 2 to jump back and forth between the palette and the blocks. I'm going to close down this dialog.
X button, hotkeys button.
And then I'm going to focus the block editor.
Full screen, run program button, enter block editor button.
I'm going to press Enter.
Block editor dialog. Palette comma, to navigate to the palette press enter dot. To navigate to the editor use the arrow keys dot. To navigate.
And then I'm going to press Enter again to go into the palette.
Label the chart label. Block editor, label the chart label. Heading level 2 navigation.
I'm going to force NVDA into focus mode. And now if I tab, I'm going to move through a few different placeholder or palette blocks that we want to set.
Chart : set title left paren, quote penguins quote right paren, comma, button.
So this is our set title block.
Chart : set subtitle left paren, quote bill depth vs bill length quote right paren, comma, button.
We have our set subtitle block.
Chart : set x-axis title left paren, quote bill depth quote right paren, comma, button.
We have our set x-axis title block.
Chart : set y-axis title left paren, quote bill length quote right paren, comma, button.
And finally, we have our set y-axis title block. So for each lesson, we've kind of scoped things in to only include the blocks in the palette that you'll be needing to complete the lesson. If you were to use Quorum Studio, the actual downloadable IDE, you would have quite a bit more information and detail in the palette. But for this, we tried to keep it very scoped in.
New notification from
basic.
Discord, comma,
So we want to place each of these blocks into our program just below the scatterplot chart block. So I'm going to move back to the set title block and select it to put it into placeholder mode. I'm going to shift tab a few times.
Chart : set x-axis title, chart : set subtitle left paren, chart : set title left paren, quote penguins quote right paren, comma, button.
Okay, so I'm focused on our chart set title block, and I'm going to press Enter to move into placeholder mode.
Chart : set title left paren, quote penguins quote right paren, comma, block.
So now our block is in placeholder mode in the code editor on the right, and I'm going to use the down arrow key until I find that scatterplot chart block.
Use libraries.interface.controls.charts.scatterplot, comma, blank, comma, block. Data frame, comma, block. Frame : load left paren, quote data / penguins1.csv quote right paren, comma, block. Frame : select all columns left paren, right paren, comma, block. Scatterplot chart equals frame : scatterplot left paren, right paren, comma, block.
Okay, so this is the block I want to place it under, and I'm going to press Enter to put it there.
Scatterplot chart equals frame : scatterplot left paren, right paren, comma, block.
Okay, and now we still have a few more blocks in our palette that we want to grab, so I'm going to try pressing Alt-1 to jump to the palette.
Label the chart label.
Okay. And then I'm going to tab down to our set subtitle block.
Chart : set title left paren, chart : set subtitle left paren, quote bill depth vs bill length quote right paren, comma, button.
Okay, so now I have our set subtitle block focused in the palette, and I'm going to press enter to move it over to the code editor in placeholder mode.
Scatter plot chart equals frame : scatter plot left paren, right paren, comma, block.
And it is already placed just below the scatter plot chart equals frame scatter plot block. So I'm going to press enter.
Scatter plot chart equals frame : scatter plot left paren, right paren, comma, block.
And now that it's placed, I'm going to jump back to the palette and do the same thing for the set x-axis title block.
Label the chart label.
I'm in the palette now, and I'm going to tab down to the block I want.
Chart : set title left paren, chart : set subtitle left paren, chart : set x-axis title left paren, quote bill depth quote right paren, comma, button.
I'm going to select it to put it in placeholder mode.
Scatter plot chart equals frame : scatter plot left paren, right paren, comma, block.
It's below the scatter plot chart block, so I'm going to press enter to place it there.
Scatter plot chart equals frame : scatter plot left paren, right paren, comma, block.
Then we have just one more block we need from our palette. I'm going to press Alt-1 again.
Label the chart label.
And then tab down to the block, set y-axis title.
Chart : set title left paren, chart : set subtitle left paren, chart : set x-axis title left paren, chart : set y-axis title left paren, quote bill length quote right paren, comma, button.
Okay, I've got the block I want. I'll press enter to go to placeholder mode.
Scatter plot chart equals frame : scatter plot left paren, right paren, comma, block.
And then I'm going to place it with enter again.
Scatter plot chart equals frame : scatter plot left paren, right paren, comma, block. Button enter block editor, hotkeys button, X button.
Then just as a reminder, if we want to run the program, we can use Alt-Shift-R to run it right from the code editor.
Block editor dialog, block.
So Alt-Shift-R.
X button hotkey shortcuts heading level 6, list run program Alt plus Shift plus R, block, unknown.
None. That hotkey
Data
doesn't
Science
seem
Hour
to
of Code Activity 2 bar Quorum
be
Programming
working.
Language Document Busy 1 Trying other charts.
I refreshed the page, so I'm gonna get some of these blocks placed quickly and get the program running.
Block editor dialog, chart : set title left paren, quote penguins, chart : set subtitle left paren, quote build, chart : set x-axis title left paren, quote bill depth, quote, chart : set y-axis title left paren, quote bill length quote right paren, comma, main landmark button hotkeys.
Okay. Sorry about that. We're back to the state we were at with all of our correct palette blocks in our program, and I'm going to focus the run button. I think the hotkey may be having a slight bug.
Activity : heading level 2, blocks heading level 1, navigation label, cut, set, trying other charts list with penguins, hide palette button. From Amber Hodges to everyone, zoom out button, hotkeys button, full screen button, run program button.
Okay, I'm going to hit the run program button.
Build successful, console output.
There was a build successful, so I'm going to focus the game.
Stop program button.
Pressing tab.
Enter game button.
And then I'm going to press enter.
Game dialog. Penguins, comma, with 1 series and 333 points, comma, overall minimum x 13.1, comma, overall maximum x 21.5, comma, overall minimum y 32.
So the main difference here is now we have a chart named penguins. And it says that in our summary information instead of just telling us scatter plot. And if we cycle through the axes with the arrow keys.
X-axis, comma, shows bill depth and ranges from 13.1 to 22.1 dot.
It now says the x-axis shows bill depth.
To all panelists.
And it is formatted in a way that does not include that underscore. So now that we have a running chart with our new titles on it, I'm going to press escape to unfocus the chart
Button enter game.
and then move down to our questions.
Console output group 1 dot. What variable is shown on the x-axis question? Edit blank.
So our first question is what variable is on the x-axis? And the second question,
2 dot. What variable is shown on the y-axis question? Edit blank.
asks what's on the y-axis. So I'm going to go back to our chart.
1 dot. Console out, enter game button.
I'm going to enter the game with the enter
Game
button.
dialog. Penguins, comma, with 1 series and 300.
And then I'm going to navigate to each axis and see what's on there.
Y-axis, comma, shows bill length and ranges from 30 to 65 dot.
Okay, so the y-axis is bill length.
X-axis, comma, shows bill depth and ranges from 13.1 to 22.1 dot.
And the x-axis is bill depth. So I'm going to press escape and go submit our answers.
Button enter game. Console output 1 dot. What variable is shown on the x-axis question? Edit blank B-I-L-L-D-H.
Now I've typed in bill depth for the
2 dot.
x-axis.
What variable is shown on the y-axis question? B-I-L-L-E-G-H.
And bill length for the y-axis. And I'm going to
Submit answers button.
submit my answers.
Correct dot. Correct dot. 2 of 2 correct dot.
Okay, and we've got both of them correct. So that gets us through the first 2 lessons in our hour of code. From this point, we would move on and we would get into a larger data set with more column types. We would select different types of data in the 3rd lesson. We would try to separate that data based on different factors or categories. We could customize the colors and then separate the chart into subcharts, so a lot of little charts. And finally, try some of the other chart types like histogram, bar chart, and pie charts. That is our hour of code. I think I can pass it back to Leslie, maybe.
Yeah, wonderful. Thank you very
Activity
much.
colon.
Was there
Stop screen sharing.
anything else you or Alex wanted to share?
I think that's pretty much it.
That's it?
The only
Oh.
other thing, we did recently do an update on the site. There is that option to try using this with a tablet, but I will say it's a little bit rough still. We will be doing more enhancements to that in the coming months, though.
That's exciting. Thank you very much, all 3 of you. What really got my interest in this is when I was a TVI, we had so many classroom teachers. Oh, you've got a few minutes, just jump on and do an hour of code. Just jump on it. You choose any hour of code. And there just aren't that many that my students could use. And you can use the filters on the side to search, but it's tricky and some are pretty outdated now. So this is very exciting that this is a one that is now available.
Jim, Leslie, this is Erin. There was a question and I'm not certain if it was answered. What are the blank spaces for? Are they supposed to stay blank or for something to come later?
Those blank spaces are blank blocks. So if you were writing a program, sometimes we'll just press enter a few times to leave space in between. So they don't actually have any functional purpose other than to leave some separation between, I guess, logical sections of the code, but completely unnecessary. Just something I do, I guess, as a programmer.
Thank you.
Were there any other questions that people have for Tim or Alex? We still have them here.
Leslie, I just noticed another comment that they might be encouraged by it. So they, one of our participants, they was saying they were doing it on the iPad, following along with the iPad. So
excellent, excellent. So we had people following along with you. Well, Tim, you might have to work on some more lessons.
Yeah, hopefully everyone enjoys this and maybe we can come out with some more.
Excellent, excellent. Thank you very much. And if people want to continue to talk about this, encourage each other, you can join in the accessible coding community in the APH Hive. There is a discussion board there. And we've really seen a lot of camaraderie in some of our other discussion boards and people helping each other out and answering each other's questions. So I highly encourage that. But I'm going to say thank you once again to Tim and Alex, and really appreciate you coming on and sharing this. This is a great tool for us to share around. Thanks. Next up, we have 2 more participants to share about accessible robotics. Super exciting, super scary to the some, but I think Amanda and Gina will take away a lot of those fears and show you how you can go through step by step and make a Finch fly. I'm going to just hand this straight over to Amanda Rada and Gina Fugate and let them introduce themselves.
Leslie, hey Gina, just before we get started, Louis, your question, I think, is what Tim linked the Quorum language /learn website for, on how you can learn to build apps. Yes, you can do apps in Quorum. So sorry,
Thanks for
I just
catching
saw
that.
the question
No,
and I wanted to make sure we covered it for him, so you knew
thank
where
you.
to look.
Okay, and Amanda, can you hear me?
Yep.
Okay, that's always my worst fear is audio. All right, hi everybody. If we could switch slides, Amanda, I think you're up first.
Oh no. Okay. Hi guys, my name is Amanda Rada. I use pronouns they, them. I am on year 19 of teaching, 14 years of teaching blind and low vision students, 12 years of teaching computer science to those students. I have an MED, which is a master's degree in educational technology, as well as blind and low vision education. And I am an EDD candidate at the University of Florida, computer science education, curriculum, and instruction. And I am focusing on access to computer science for our low vision and blind students, as well as some other low incidence disability learners. So I've been doing programming for a really long time. My first language is Quorum. And back when Epic wasn't even Epic yet, last year before it was named, I started working with Andy and the Quorum team and fell in love with using Quorum. And I have taught everything from some of our lower learning middle schoolers and elementary school students up through AP computer science principles using Quorum. And had a student get a 5 using Quorum and AP CSP. So it is possible to do very high level work. And then I met Gina, and now I also do robotics. I will let Gina introduce herself.
Hi everyone, I'm Gina Fugate. My pronouns are she, her, hers. For your bonus information, I am wearing a shirt covered in monarchs and a very nerdy, purposeful reference to the Monarch multi-line braille display. I have a bachelor's in English education, so I am a person who did not start out with any intention to do computer science, but people like Amanda here and Stefik converted me over to the code of the bunny, as well as Python, which I call the code of the snake. And we have lots of many other jokes. So happy to be here. I also have a master's of education in visual disabilities. So that includes instruction in Braille codes, which is covering literary and Nimith. I also have what I call CADIS status. So I have an assistive technology certificate, and I just renewed my CADIS certification through ACVRO. I have teaching experience in Tennessee, Kentucky, and Maryland, but unlike Amanda, I don't like always counting up all those years and talking about time. So I'm going to skip the number of years, but it's plenty. But Amanda is one of my mentors. And lastly, I am also a current EDD candidate at the University of Florida. So Amanda and I are going through that journey together, supporting each other. And we are both ABD, which is clearly for all but dissertation. And stay tuned because I'm sure we'll be reaching out to the community later. Next slide.
Definitely.
Next slide, please.
I see the mouse. There it goes.
There we go. Glad you saw it. So this is always a picture that I love to show. I became a person involved in computer science and robotics because of the students here at the Maryland School for the Blind. The previous coach had left, and it was the students who really cared about robotics and they wanted it to keep going. And who can say no to their kids? So to emphasize how important it was to them, this is an older picture, but it's a really important picture because it's showing students at the Maryland School for the Blind presenting to Lego reps, and that would refer to reps that had been based in Denmark. And they're also with Stefik on a video call. We had other guests that day, including Humanware and NFB, the Maryland State Department of Education, but the students asked to have their picture taken with Stefik. So Stefik is on that screen somewhere, posing with students who were from an on-campus team as well as an off-campus team, and that was an all-day presentation. So that is how I got into what I do, and that's how I've also learned to cope with robot season, even when Stefik creates things during robot season like he just did with Spike. So that is a very important part of the story. If we could go to the next slide, please. So here we are to talk about Finch. There is this lovely robot, which is known as Finch 2.0, and it is from Bird Brain Technologies. It has won awards for the best of STEM, and it has all kinds of features. We have listed all of the features today just to share out that information. We are not going to cover all of these, but we are going to make sure that anyone attending today will have sample code that they could automatically run on a Finch, that they'll be aware of academic standards, and we hope to give you some strategies and tools to make you more comfortable with getting into code. So just really quickly, some bonus information on Finch 2.0 includes that it has really long battery life. It can almost last a full school day, depending on how many times you're running that Finch and whether or not you might give it a little bit of a battery charge in between classes. One of the purposeful features of Finch, which we are featuring, is its ability to draw. So in the center of the top of the Finch, there's sort of this gray area that has some Lego studs, and there is a plug in the middle of that. And when you pull out that plug, you can stick a marker down there, and it allows you to draw different shapes. This actually goes way back in the computer science education community, and Bird Brain Technologies purposely incorporated this into their design for computer science education. Line tracking, radio messaging, light sensing, obstacle sensing, sound sensing, full color LED lights, a buzzer capability, a compass, and then plastic brick adapters referring to the Lego studs. So that covers all the text that is bulleted and listed on the screen. And then there's a logo featuring one of the awards that it has. Amanda, is there anything else that you'd like to add to that?
Talk about the brain of it being a microbit.
Oh yeah, the brain of it is the microbit, and the microbit is that little chip that's kind of in the tail. A microbit can be purchased with the Finch, or it could be purchased separately. The whole thing is definitely under $200. So next slide, please.
Yes, you can use Python with this, and we will talk about
Amanda, your volume is muffled on my end.
that. Oh no, can everybody else hear me okay? Cannot hear. Excellent. All right, hang on a second.
You are really low at the moment, so I'll talk for a few minutes and give you a chance to work with that. So Finch 2.0 doesn't require any building, so it's actually become one of the favorite bots here at MSB. Though we have always done Lego, and Lego's pre-Gina, goes back to 2012. Lego requires a lot of fine motor, and the Finch, when you pull it out of the bag or the box, is already built. All you have to do is figure out how to put that chip in there, and then make sure that you insert the marker correctly when that time comes. So the first photo is showing a case of finches, and they have been taken out and put on the table for the most part. 5 finches makes a flock. That is the terminology that bird brain technology uses. And you can also get the special markers that are designed to fit into the finch. And you can get a direct USB hub if you order a flock of finches. You can also order them individually. The second photo was taken here at MSB, and it is showing a finch that has drawn a triangle. It's on a whiteboard, and there's a Braille display there. So Braille display users, you can use Quorum Studio. You can access code on your Braille display of choice, and you can draw these shapes. Amanda, did you?
Hear me?
Yes, that's better.
Excellent. I think I was trying to go through my headphones and those died. So
Okay, anything to add there, friend?
no.
Next slide. Okay, so this covers Finch standards and Common Core math standards. So it's important for our audience to know that there are 2 hyperlinks featured in the bulleted areas. The first one goes to the BirdBrain website, where they have laid out the math standards for Common Core math up through 8th grade. So when you are justifying the use of robotics or how you're using Finch 2.0, that can help you meet academic standards. Also, the second link is to BirdBrain printable drawing, and it emphasizes shapes. In that case, there's triangle, square, are a couple samples of the shapes. Then it has a chart for students to note the number of sides, the number of angles, and the specific angle. Measure the side length, the perimeter, and the area. So it gets very heavy on math application. And what we're going to give to you today complements this worksheet, but also expands to give you even more sample code that you could do. So all of it was inspired by BirdBrain itself. And then this last bullet is emphasizing Magnetiles, graphic art tape, any tactile shapes of any sort, foam or 3D printed shapes. Tactile graphics could be used to make hands-on manipulatives. So one of the things that we are often asked is, if we're putting a marker in our Finch and we're drawing on a whiteboard, how is that accessible? And Amanda introduced me to angle legs. So I'm holding up a set of them here, but they're also featured in the bottom right corner of the slide. And Amanda, could you add to that, because you're the math person?
Yeah, so Angle Eggs, which actually the picture in the slide is not that company, and I want that company that's in the slide, which is Junior Geosticks, because it has circles. But Angle Eggs are just plastic straight lines of different lengths that you can easily snap together to make different geometric shapes. I have used them a lot with my students in math. That you can make the shape that they're going to draw and to explain how the angles work. There we go. That's the word I'm thinking of. So the angle legs are different lengths. So you can force acute angles, obtuse angles, specific triangles, specific other shapes. And they're very easy to use. They come in different colors. They're a lot of fun. In my experience, students all the way up through seniors in high school, as well as college age students, just kind of enjoy building with them. So they're a nice added tactile addition.
So I would add that you can clean them with a Clorox wipe or literally like wash them. Amanda and I both use them during a training this summer. So you can make that hypothesis of 90 degrees. Is 90 degrees being shown by the student with the angle legs, and then comparing it to what was actually produced by the Finch. I always lean on Amanda because with robotics, when you're doing angles, sometimes it can get really confusing of is the turn that you are predicting an acute angle or an obtuse angle? And so that is a concept where I always call on Amanda. Next slide, please. And then again, just emphasizing when Bird Brain Technologies, and Tom Lowers is the person who designed the Finch, it was specifically designed to be used with Crayola paintbrush pens. So the photo shows the packaging of the pens, and this is the exact brand that nicely fits into a Finch. People will usually ask me if other markers fit into the Finch. To my knowledge, other marker brands were not designed to fit into it. So it's not that it would be impossible, but I've stuck with what I know it was designed for. If anybody out there has discovered any other brands or possibilities, it would be great to know. These are widely available through Amazon, craft stores like Michael's. You can order them directly through Crayola. One of the hardest things, ironically, when you get a Finch is to figure out how to take out that plug. So I'm holding up a Finch. And if you take the marker and you stick it through the bottom of the Finch, then you'll push out the plug. So mine is already removed. Don't put your marker in so tight that you get it stuck and you can't get it out. But if you do get it stuck, just like twist it and it'll eventually come out, and then you'll know not to do that again. The other thing that's important to know is to remove that cap. So that's in the directions, and I'm being very dramatic. Taking off the cap goes through the top of the Finch, and when you put it in there, there's a click sound. And then the tip will be just right for when you put it on a whiteboard in order to do different shapes and things. This also can work on paper like bulletin board paper, construction paper, anything like that. Next slide, please. Okay, so this is where you get a hyperlink that goes to a Google Doc, and it gives you all of the code to do all of the shapes in this list. So there's 10 different shapes, beginning with a line, and then a triangle, a square, rectangle, pentagon, hexagon, a 5-pointed star, an octagram, an octagon, and then a circle. And our thought process in with this was to be able to provide teachers and parents and students with a variety of shapes that they could work with. So some questions earlier that have been in the symposium today, and then I've already gotten some emails, was how can this apply to my student? And there's a big range of ages out there in ability, and sometimes students haven't even had any exposure to coding. So you could begin with drawing a line and measuring that line. You could then expand to how would you make a turn and make a triangle, a square, or a rectangle. Sometimes robots are used for motivation. So yes, we have the robotics team at MSB, but also robots are just fun to play with and fun to crash, as my students have taught me. So maybe it's a reward time, and that's how you get the students interested in robotics, because a lot of kids don't even think that they're capable of learning how to code. So that was our thought process. Amanda, do you have anything to add there?
As you know, as Gina has said, I not so much anymore, but I'm a math teacher at heart, and I absolutely love once kids know what a shape is, right? We know what a square is. Having to program out how to actually make a square, and then having to learn, you know, okay, I told it to go 3 revolutions. How far is that? So measuring that line and adding in all of those little tiny standards of measurement and shapes and angles that students struggle with and that are kind of, let's face it, boring when you don't have a reason for them. It's a great way to reinforce the skill that you've taught in a way that is like, oh, I'm using this for the robot. And then, yeah, you're using a little Finch to draw a line, but we use robots in real life. We have the NASA rovers, right? Those robots, they have to know exactly how far they're sending that robot. They have to know that knowledge. So connecting the fact that you made a square on a little itty bitty Finch to the fact that there are scientists and engineers and programmers who then, you know, use that on Mars, and learning the basics in Quorum on a Finch lets you be able to do that job, right? So it's one of those, why do I have to learn this kind of connections for kids that, you know, we hear a lot in math, a lot. And Amber asked, have we used it on quick draw paper? Yes, it does work on quick draw paper. Of course, quick draw paper can be a little bit expensive. So that is at your discretion. It will create the raised line with marker because it is just a water-based marker.
And a strategy with the quick draw paper, the quick draw paper is 8.5 by 11. So if you take multiple sheets of that paper and tape them together, you can kind of simulate what would be bulletin board paper. So that was also helpful for us. If you don't have that, then graphic art tape could be a great way to make that tactile. And I guess we haven't explicitly said it, but you know, Finch uses Quorum. It can also use Python in multiple languages. So this is a great opportunity for this tool to be used in any computer science education experience. So Quorum was really designed for everyone, and this could be celebrated out in general public school classrooms, as well as schools for the blind and boys and girls clubs and all sorts of settings. So that's part of what I think we're really hoping for, is for the community to realize that, embrace it, and share out this information to everyone. Next slide, please. So this is a snippet of the snake, aka Python. So Python is another coding language that is commonly used. And we have a hyperlink for you that goes to what is called the Python browser that is produced by BirdBrain. It does work with a screen reader. So it is accessible. It's a little challenging on usability, but it totally does work. So if you are new to using a screen reader, or you run into any trouble, Amanda and I are both sharing out our contact information. Please feel free to reach out to us with questions. But we would even challenge you to purposely consider both languages. Maybe you start out with Quorum and then, you know, see what you think of Java. What's the big difference between these? And why are people always talking about what language they know? Though I would say the truth is they probably know more than one language if they're in that conversation with you. So we provide a snippet of code here, which is Python, and it has a lot more punctuation and syntax in it. So the very first line is somewhat similar to Quorum. It would relate to the used libraries. And in this case, it's from BirdBrain, import Finch. And then we go down, there's a blank line. The next line is bird space equal sign, capital F, open paren, close paren. So that's declaring our Finch object. When we get down to running a loop, this is where Python is a great example of something that I'm just going to say is a lot more wordy. So for, not the number, FOR space I space IN space range, open paren, 3, close paren, colon. And you need all of that to begin your loop to run these lines of code. So you're telling it to loop 3 times for the next 2 lines of code that are there. And if you compare that to Quorum, if you're going to repeat something 3 times in Quorum, you would say repeat space, the number 3 space, the word times. And then you would want to end your loop. So there is quite a comparison in the syntax between Quorum and Python. So that's just something for students, teachers, and families to consider when comparing languages and thinking about how much has to be listened to on a screen reader or read on a braille display, or for any user doing languages, what are the benefits and challenges of using any language? Next slide, please.
We have a couple of questions in the chat that I just want to clarify. We're on our contact information page anyway. The Swell Touch paper with the black marker that it comes with. So the last time I used one, it had both a fat and a thinner marker. I think that the thinner marker would fit in the Finch. You could try it. And if it's too skinny, you can always wrap tape around the middle of it to make where it has to hold a little bit fatter. I did use a thinner, like the thin markers from like Crayola markers in a Finch. You just can use duct tape or masking tape in the middle to make it fat enough to sit in the right spot. So if you kind of played with your marker a little bit first, it would work. And then I assume you mean to run it through a POF or a swell machine to make that tactile. It would totally work. Again, that paper can be a little pricey, so use wisely. But I totally get letting the student have that tactile actual experience of what did my robot draw. I think that would work really well. And then Gina, somebody asked if the Python link only works on a desktop because they were trying it on their iPad. And I didn't know the answer to that one.
So I think it is possibly only on Windows. I don't know, honestly. So if we could get back to you on that. For my students, we've done Windows laptops. So I haven't tried it on an iPad. That's a good question, and we'll have to test that out.
You did an error. So you're getting an error saying you don't have a new enough version of Chrome, but you're using Safari. So obviously it is asking you to use Chrome. The online links to the BirdBrains browser, the BirdBrains Python, yes, will work on a Chromebook because it is web-based. It's not a downloaded software. Correct, Gina?
I think so, but I would need to double check it. That does make sense with the logic you shared.
Actually, there is Chrome for iOS, but they are all Safari in the background anyway. It's just the skin they put on top. That's a whole different tech talk.
A whole different tangent.
There's a
That
whole different tech talk. I love iOS for some accessibility. Other places it fails and fails hard. This would be one of them. It's not kept up with a lot of things that are educationally based.
So this is a great example of knowing different types of technologies and operating systems reflects different skills and different opportunities. The Bird Brain Technologies page does outline what software is available, and there are other things that Bird Brain can work with that are not necessarily accessible, like Snap. It can do Java. I haven't tested that one yet. So if you're asking questions, we'll definitely try to follow up and send out some answers, but it would also be great for you to check out that website and see what you can find too.
Yeah, if there are any other questions that we missed, they scrolled through real fast at one point.
Like,
They're very excited all at once, which I love.
We're very open to questions, so don't worry if you have
Yeah.
a question. Don't worry about it not being good enough. Something we hear a lot. All questions are valid.
Unless I literally just answered. Just saying.
I mean,
That's just what I tell my students.
You're looping.
Any other questions? What is the website where I can find the link with Python? Do you mean the Bird Brain website? That
The Brython website?
I can relink it because I have copy and paste powers. There you go. If that's what you meant. Yes, I definitely use a PC for coding because I like PCs. I'm fairly anti-Apple. iPads for coding, I don't really recommend. They're just not as robust. Coding that is more like a game, sure. Like I know we have some apps that are designed to teach coding, and those are great, but then they end, right? You complete what the app has programmed out for you. I'm thinking specifically like CodeQuest. And then it ends, and you're left without a language to use on your own. And it's not as robust. It is not as career ready on just an iPad. Learning to use some kind of laptop PC or a Mac for that matter. I mean, it's fine for programming. I just don't like them personally. That's just personal opinion, not the opinion of anything I'm related to. Knowing how to use an actual computer of some kind is more career ready for you. There are many jobs that you can use a tablet for. There are many jobs you need a tablet for. Transferable to the career world, knowing how to type on a keyboard and knowing how to access a computer and software and web-based products on a computer is what you need for industry, for careers, for a job. That's really the big step. And when I say learn to type on a keyboard, Braille displays are completely valid. Use a Braille display, no problem. As long as you know how to set it up and connect it. That's a skill you have to learn moving forward, is how to connect your own tech. Right? That independence.
And so a Braille display would be an opportunity for you to edit your code too. So you have the ability to read, you have the ability to edit. If you are a person who has a Monarch right now, using that monarch to look at the sample code resources that we've given out today. Your monarch could be sort of like your reference guide for your Finch, and then you could be using your device with your Finch to do the live and active code that is similar to what we have done here. Also, I dropped the link for BirdBrain and the portion of the page that is focused on the Finch and gives
Amber, it's the link above your question.
It's saying what it is compatible with, what kind of devices, and it is also outlining the languages there. Quorum has not been added to that chart, so I want to point that out, but they are listing Finch blocks, Bird blocks, Snap, make code / JavaScript, Python, and Java. So hopefully Quincy, the Quorum Rabbit, will be joining them soon. So I think we still have a little more time.
You do, Gina, and Stephanie just shared the sample code that you provided, so people can take a look at that as well.
So since I have this set up, I'm just gonna show the Finch running.
Yes, can we pen Gina or switch from share screen to Gina big so people can see when she runs the Finch? Because that's the cool part.
So I'm going to turn the Finch on. So that's a press and hold for 2 to 3 seconds. And it looks like I'm already paired. Normally it would show letters flashing. My Finch's name, and something that we didn't necessarily highlight, is that Finches have alternate names. So when you go to the BirdBrain website and you are pairing your Finch, you will find out what your Finch's other name is. So this Finch is called the Playful Crystal Hippogriff. And now I'm switching screens. Amanda, what shape do you think we should do? Any thoughts?
I don't know. Quick, first person to name one of the shapes in the chat, you get it. Ready?
That's on that list.
On that list. Octagon, octagram, pentagon, pentagram, square, rectangle.
Are they posting that?
Oh, somebody said it. Pentagon.
Pentagon.
Oh, pentagon and then a star. So, okay.
All right. So I'm pulling that up on my computer and all should be well. So I have that code preloaded. So all I have to do is run that code. Oh, and I didn't put my marker all the way down, so I'll run this again.
I see.
Enjoy the virtual presentations.
Stephanie, we do not have a Mobius strip programmed. That is your new task. Ready, go.
All right, so I'm going to pick up my Finch. I'm going to push that marker down, realign, and then I'm doing Control R. So another skill of finding, why is that still not going down? Now I'm grabbing my Finch.
This is problem solving that we often have to do on the fly.
This is called debugging.
It's called debugging. It's a part of tech.
So this is probably a good time to say that Finches are incredibly durable. But this is my oldest Finch. And yeah, that's trying to pop up for some reason, which I literally have never experienced before. But here we go again. Gina put the marker in correct.
Goes. Good job, Gina. You can put a marker in a robot. It makes such a nice, pretty one. Look at that.
So something
You
else that
lost your last two lines though, didn't you?
what in the world? We're showing flexibility in debugging. Something that we didn't mention and that we haven't done in a public presentation yet is that with these Lego studs up here, you could add minifigures and make your rules on what could be used, but you could actually have your finches do jousting matches. So if you're interested in the finch, Google it, look at the videos and things that are out there. We've seen dances. Amanda and I did a dance technically with the finches at Epic. There's a lot of possibilities for this little robust robot, and APH has also celebrated the finch as well. So we look forward to more collaborations, and I'll have to figure out what's going on with my markers. I will say a new strategy that I haven't tested out is someone told me that they were using Play-Doh to put that around thinner markers that wouldn't necessarily fit in there well, which I think is brilliant because when you take your marker out, this is all plastic. Like you're not going to hurt anything. There's a little bit of rubber. So if you get Play-Doh in there and it dries out, there's no damage worries for the inside of the finch.
Yeah, it is sealed. So like where the marker goes through isn't going to like break a motor or anything like that. It is sealed and protected.
What was the other shape, Amanda?
Star, Mobius strip, hexagon.
Star, 5-pointed star we had on there. So my assistant is going to come in and clean things mysteriously.
Good job, assistant. Excellent. Excellent. Extra credit gold star for you today.
And so I have code up, and if you follow things through with that document, a strategy when running any code that I've learned from my students is to make sure that they read the code and figure out which way it is turning so that you know where to put your finch. So the code tells me that I'm going to move forward and then it's going to turn right. And so that is something to pay attention to so that you can think of where your finch needs to be spatially.
Daniel, when Gina and I wrote the dance that ours were doing, they did fight. We just had some technical difficulties with internet when we did it, so.
I don't know what's going on with my markers.
It is drawing a star. It is just not leaving its mark. It's practicing leave no trace of hiking. That is what it is doing right now.
So in the bags there, I think there's some other markers inside the finch bags. I think we're going to try switching things out. And he knew better than to give me the yellow.
I ended up with like 5 yellows. Why? Why do people give me all the yellows?
Because they make my eyes hurt. So I didn't really say, but I have an eye condition. So when there's low contrast things like yellow, I always give them to my sighted friends like Amanda. All right. So we're going to see if this resolves it. And if not, I could switch out finches, but I'm curious now. Much better.
That one works.
Will it stay?
We now have a green star being drawn.
We also have,
part is that it runs over its marks and we'll smear them.
and it makes like little curves with those turns on the wheels.
It makes like arc marks. It's amazing.
When you use something to clean your wheels, that marker will come off of the bottom. And I'm gonna lay my finch upside down over here. Sorry, Finchy. And lift this up a little bit so that it is easier for people to see as I'm going to send a cat flying. So pretty simple. And you could adjust any of these codes to make something bigger or smaller. We started out trying to cram everything on the 8.5 by 11. but that really is a very tight space for wheel turns and making different shapes. So if you are planning on getting this robot and thinking about code, you definitely want a whiteboard or workspace that is bigger, a bigger surface for you to run your Finch, particularly if you're doing a whiteboard. Okay, are there any questions given with all that?
One thing that you can add to add some auditory kind of feedback to when your Finch is running, I had it play a sound while it turned to just kind of key that it was turning in a direction, and I had it, you know, do a different sound if it was headed to the right or to the left, those kinds of fun things, which also lets you know if you wanted it to turn right and you notice that it went left. That helps you remember what you wanted your code to do. If the right turn noise goes off and all of a sudden your Finch is headed to the left, you made a mistake on one of those two things. So that's just, and it's very easy to add that sound to it. It's just one little play line of code. And also
That's
to add noise to anything.
That's a great strategy for robot tournaments too. And again, that's a great strategy that would help out anyone. One year we did a different animal sound for each move on the first Lego League mat. So we had dinosaurs and meowing and barking. But most of the robotics community really has a good sense of humor, and it helps everyone know what you're doing. So it's a great collaborative opportunity. I think we'll go ahead and mention too that, you know, if you're not wanting to do competitive robotics or crashing Finches together for jousting, you can have dancing robots too. And one of our good colleagues, Tim Lockwood, is known for his dancing robots. And this summer, someone had also had the Finch draw an owl and played a song related to that owl. So the possibilities are
famous movie where white owls deliver notes. It played that song and drew an owl wearing glasses.
I barely stopped myself from saying the title. So the possibilities are really up to you. It's really unlimited. So if you're interested in robotics, just think about what you want to do with it, brainstorm and do some research and reach out for help if you need help.
There's a question, Gina, real quick. Is there any haptic feedback for persons who are deafblind? I don't think so on the Finch, other than the fact that it moves.
Correct. Not that I know of. Like, I have had students who were able to, grabbing my Finch because I left them sideways, which is not nice, who were able to lightly touch and then the Finch was still able to move. So in that case, if we back up a little bit, if you're familiar with Code and Go mouse out there and it has like the tactile pieces, that might be a good place to start. And then you could move onward from Code and Go mouse up to the Finch or other things in order to make that accessible. My phone is ringing and I'm not answering you.
Mine was just ringing too. And I think that teacher just walked in the room.
So our contact information is out there. We both listed our emails. Please don't hesitate if you want to reach us. And the Quorum community is very active on Discord. So if you have access to Discord and want to join that community, there's no strings attached, so you can be on there and just enjoy the chat. People often share their code and the community is very inclusive. If somebody posts a question out there or makes a request, not only is it usually answered, and Amanda and I both made requests before, but it's often answered by Stefik and his team directly within a very short amount of time. So the Quorum team is completely biased and favored towards it because of their response time and their accessibility.
Oops.
You're super zoomed in right now. On the
Yes,
screen.
I realized that. There we go. I was trying to be prepared and then it got away from me. Sorry about that. Thank you. I was thinking that when Tim was doing he with the Finch this summer, he did a compass with his Finch, and I recall it vibrating some when he did that. So there must be something in there, but I invite people to try things out and share those. Another one is I discovered a line following option. It's got those funny eyes in the front that are sensors. So I challenge somebody to draw a line and see if you can get your Finch to follow that line. Then you could use any kind of raised tool to do that. So there's, I think, a ton of opportunities
I
here.
also used the Finch as a remote control for a video game. So I had a video game and the controller, you tipped it forward, my person walked forward, you tipped it back, he walked backwards to the right, to the left. I had hooked the Finch up using Quorum that way. So
that is really cool. Okay. So the sky's the limit. With your limit is your imagination. Teaching tool for math, getting students interested, doing dances, doing drawings. Like this is a very, very fun thing here. And it's a cute little bird thing. Well, where can you get a Finch? You can order them through Bird Brain Technology. I know, and I think we have dropped that in the chat. And next, we are going to do a short break before we have our last presenter, because I'm sure everybody wants to stretch. So we'll be back in 15 minutes. And thank you very much, Amanda and Gina, soon to be Dr. Amanda and Dr. Gina. And this was great.
Thanks for having us.
Absolutely.
Welcome back, everyone. Hope everyone got a second to stretch. We're in the home stretch. I'm not sure, Leslie, I couldn't hear your audio.
Oh, yep.
There you are.
There I am. Zoom's having fun with me today.
Yeah.
Thanks for hanging in there, everybody. We are getting close. We have just a little bit more to go, and then our final presentation. So let's get started with just a few words from our sponsor. We have the distinct benefit to receive funds to support the Coding Symposium and Days of Code through the PPG Foundation and the Fox Family Foundation. These are great sponsors. We've had them year after year, and the Fox Family Foundation in particular has a very unique program that we thought some people might find interesting, specifically around career development and visual impairment. So I think we have a short little video. Jeff?
So let me see if I can get this to work. Can I just get a confirmation that everyone can see the screen? Or
Yeah.
anyone who can't see the screen? Can
It changed.
Yes, Jeff, we can see the screen.
Here we go. Let's see if we got this right.
Yes.
And we have sound.
How do you create a world for everyone? Envisions.
It's a movement for inclusion.
High school and college students innovate to respond to obstacles and reduce exclusion faced by the disability community.
To change the world.
In 2025, an Innovate contest opens with more than cash prizes.
Organizations committed to inclusion are offering internships to select participants who find solutions which impact lifestyle,
Assistive technology,
public spaces,
empowered employment,
and support systems. Take whatever you are passionate about and build solutions that are inclusive.
get mentored by subject matter experts.
Envisions is a program that I went through that opened my eyes to new perspectives surrounding people who are visually impaired or people who are disabled.
What I liked most about the program was working side by side with people with disabilities, and it really got me thinking that the world was created for one type of person. And I realized that I could change that, which had to be my favorite part of the program, really developing a flexible mindset.
Envisions is a program that teaches you entrepreneurship and how to become an entrepreneur, while also incorporating all audiences and understanding the importance of inclusion and accessibility.
The world is becoming more diverse.
Major companies recognize advancing inclusion is in their best interest, both socially and economically.
You are the leaders and hiring managers of tomorrow.
Creating side by side with people with and without disabilities
Leads to a future where universal design, accessibility, and inclusion are thought of first.
Be a part of empowering change.
Envisions.
All right, well, thank you.
All right.
Off my place so you don't pick that up on the microphone. So you can find more information about insights if you follow the link on the Coding Symposium webpage. There's actually a link to the Fox Family Foundation, and they have several different programs that they currently offer, and I encourage everyone to take a look at it. And they actually have opportunities for new cohorts, I believe, coming in. I think they start either once or twice a year, definitely in September. So I encourage all of you to take a opportunity to take a look at it. They've got some really great things going on. It's a fairly new program, so if you haven't heard of it, it's just kind of gotten underway this past year. So we are very grateful for the support of the Fox Family Foundation.
And their website just grows every time we look at it. So check that out. So next up, since we have you all here and we really want this to be driven by you, we would like to know if we're going in the right direction here, if there's other things that we should consider for next year. So we have a couple quick polls. If we can launch those.
Yeah, I just launched it. And this is coding in your community. So the first question is, what programming languages are currently taught in your school, district, and/or agency? And we have a list of, we have not a definitive list, but we have Python, Scratch, Quorum, HTML, Java, and Swift listed. Question number 2 is, how is coding being covered in your school district or agency? Because we know a lot of things happen outside of the school day. So our choices that we have listed here, again, aren't finite, but effective elective classroom, required class, after school or a club activity, or based on student interest or self-learning. And the third question, what applications and/or equipment do you have to support accessible coding? And among those are 3D printer, an embosser, braille display, robotics kits, the Code and Go mouse and Code Jumper, or any other APH product for that matter. And the final, oops, I had a little extra one. Sorry about that. Choice 6, that's nothing there. My apologies. And the final question, number 4, is what do you feel is missing or would assist you or your employees' initiative to support accessible coding? And that is an answer that we're just looking for. We will be taking a look at it, but we appreciate any input that you all have to offer. And we will use this to hopefully guide us into this next year.
So we'll just give you a few minutes to fill this out for us.
24% of our participants have submitted, so want to give a little bit of time for the short answer or long answer.
Well, and with the this year doing so much around our days of code, I want to make sure everybody knows that we were doing a recap of those days to see everyone's exciting activities and innovative ideas on January 22nd. So you could definitely come back and join us for that webinar. We wanted to give everybody enough time to finish out their days of code. It's been a very, very busy fall, but we've had 5 excellent host sites around the country, and everybody did it a little bit different. So if you're looking for some ideas, some lesson plans, some really clever ideas, we will be having those for you next month, January 22nd, 2025.
All right, we are quickly approaching about 50%. We usually like to try to get there. People can feel free to, oh, I'm just looking at the comments in the chat. Oh, okay. Thank you for Victoria. She's just putting a comment into the chat rather than doing the survey. You are welcome to answer any of those questions or put comments into the chat as well if you're having any difficulty accessing the poll.
Yes.
Well, we're about 43%, so I'll go ahead and end the poll. Or actually, you know what? I can leave it open, but I'm going to go ahead and start reviewing it anyway. So
great idea.
If you're still working on an answer, because we definitely want any of your short answers or longer answers, I want to allow time for that. So right now we're about at 45%. Looks like the majority of folks on, scroll up. Question number 1. What programming languages are currently taught in your school district or agency? The most common one appears to be Python at 68%, followed by HTML and Java, actually tied at 32%, followed by then Scratch at 18%, and lastly Swift at 14%.
Okay.
Yeah.
This is good to know. And Scratch, we've got something coming for you. Get there.
The second question, how is coding being covered in your school district and or agency? The number 1 most common answer was an elective class, followed closely by student interest or self-learning at 48%. 88% of you said it was an elective class, actually. After school or club activity was 44% of you said. And a required course, I'm kind of glad to see this. Actually, 24% of you said this was based out of a required course in the school. So that's exciting to know. I know more and more states and schools have adopted curriculums for making coding integrated into the general curriculum. So
yes.
Number 3, what applications and or equipment do you have to support accessible coding? The majority of you at 87% said you had access to a Braille display, so that's great news. Followed by an embosser at 78%. Next, actually very close, actually tied. We have 61% of you reporting that you have access to a 3D printer and a Codigo mouse or other APH products. So that's exciting to hear. Glad to hear that. And on our 4th and final question, again, I'm going to leave this open just for a moment while you all throw in some answers, and we will be reviewing those after the webinar. Yes. So thank you so much for your participation in that.
Yeah, thank you very much, because this will help me look for next year's topics. So sounds like I need to do some more on Python and HTML, definitely. Okay, we can handle that. So next, our next presentation is coming all the way from Madrid, Spain. We are looking at some unplugged solutions to your coding needs. When you've ever walked into the classroom and realized something's going on and your students kind of being left out because the activity that was chosen was, everybody was doing it, so let's do it too, but it was not the most accessible one. We're going to hear from Roger and Maria of Spain, and they have some great tools around Scratch, Tactile. So I will invite Roger and Maria to join us now.
Hello, hello.
Hello.
I'm Roger, and well, thanks to Leslie and and Jeff and all the team to invite us to share this resource. I will share the screen. Okay, so yeah, we are sharing with you Scratch Tactile. As you said, a lot of you are using Scratch, and it's very, very popular. And this is why we start this project, thinking about how to make it more accessible for all. And let's see, we'll share this solution with you. Well, I am Roger Oliveira, the co-founder of Systematet and Scratch Tactile, and Maria, that cannot come, but maybe can join us later. And well, who are we? Systematet is a nonprofit cooperative based in Barcelona, Spain, and we are creating resources, making teacher training, research, and inclusive educational materials. And we trained a lot of teachers in last years about robotics, STEM, and different topics related with technology and science. And most of them are women. And we impacted more than 1,000 teachers directly, and more than a lot of thousands indirectly. And we made programs for schools, for teachers. We made educational materials. Some are open in a platform that we have in our site. And we help as well Microbit Foundation organizing this Microbit Live events in Barcelona and in Madrid last year. And well, we are developing and sharing this Scratch Tactile, and we are still at the same time working in a new inclusive educational resource related with Microbit that we can share with you more about it during the next year. We are so excited about this because we know it's a very popular tool as well. And well, first of all, I want that maybe some can share in the chat something about you, about what are the age of your students, or where are you from, so we can get to know you a bit more. And well, this Scratch Tactile is an open source, an open resource, and do-it-yourself resource. So the idea is that everyone can create it using 3D printing, laser cutting, or other technologies. And we are working on making more easy to make it, and able to make it in different options depending on the staff in your school. And we presented first in 2020, and well, we started working in 2020 and we presented in 2022, and we are working on improving. We say thanks to a lot of people that has helped and has joined us on this journey. That has been amazing. People from the US, from the schools in New York and other cities, and the Scratch Foundation, of course, and Google, and other organizations, of course, in Barcelona, Spain, and schools and teachers and organizations. And so thanks to all, because thanks to all, this is our reality. So what is Scratch Tactile? And thanks for sharing in the chat. Maria has this this issue in the eyes, no? She had a tubular vision when she was a child, and so and she had 80% loss of vision in the eyes. So it was very difficult for her, the school and everything at that time. But thanks to the help of teachers and the family that has this will to help her and doesn't left behind. She was able to study a career, and now she can see better. But she always has this motivation not to help others that can have the resource that they need. It's a matter of resource, of willing, and she this is Maria when she was young. And well, and as you know, there's a lot of people with visual disabilities in Spain. For example, more than 70,000 students. I'm sorry, 7,000 students, and a lot with different type of disabilities, and a lot of them go to ordinary schools together, like in the US, this inclusion and this inclusive model that drive all the students to the same school, usually most of them, more or less 80%. And a lot in the world has not internet connection, a lot of students in the world. So we had this question, we love Scratch and all these tools, and we said, how can we make this impact to help all these children? And they can learn 21st century skills like computational thinking, problem solving, digital skills, and in a collaborative way. So children like you have in your schools, and Musa, Elizabeth, Chloe, David. So quality education is not for everyone, and we wanted to change this to reduce the digital divide in underrepresented groups. And the idea was to make Scratch the same experience than Scratch, but without the screens, unplugged, touching with vision, and without vision, but at the same time, beautiful and attractive for the ones who can see, and as well for different visual needs, and as well in a more social and collaborative way. And to make it creative, not just following paths or solving mazes, but keep it creative, like scratches. And we propose this to Scratch Foundation, and they accept us in this program, SEC program, collaborating with them for 2 years, and we create it with their collaboration and support. And now we have Scratch Tactile. So, and we decided to start from Scratch Junior, because we don't have the language, and then it's another barrier that we take away, or to help the children, and to make it universal for all the children and all the different countries. But the idea is to have the same experience, to have backgrounds, to have characters, and to have the blocks to code them, but everything tangible and accessible. And now this is the current version of the game. We can call it a game because it can be. And you can see we make the blocks with relief, so we can touch everything with contrast of colors, and the boards, we can put a backdrop in the middle, and well, we will see now. And we decided to test with a lot of different students with different needs. Even we started with visual disabilities, but then we thought about we want to make it for all of them. So not to give a separate resource for a child, but the same resource for all. And this is our our lights, no, that guide us in all the process and still guide us. And well, we test with different visual disabilities students from total and blurry vision and different types, and we learn about a lot about the relief, the colors, and we include all the learnings in the development. And then with cognitive disabilities, for them, Scratch Junior was too fast. When they press the flag, everything was too fast for them, and sometimes too small, so they cannot understand, or the icons were hidden sometimes, and they don't have all the information, and it was too much information for them. So it is good for autism, students with autism or other disabilities, because they can introduce one block at a time and learn step by step, and make it at their own rhythm, no, and time. And for example, and we can personalize a lot the stories that they love this. And for example, Chloe and David, they have motor disability and a bit of cognitive, and they love, for example, this character, no, with the wheelchair. They can choose the character they want, and that they love this one because they say she looks like me, you know. So this is very important as well, that they can feel represented in what they are doing. So if they invent a story, they invent the character, or we use examples, this should include everyone, no? So this is very important as well. So this is why we created the Scratch Cat with the different disabilities that kids love. And well, they can even they cannot pick the blocks with the hands. They can point them, and the teacher can help to make the program, and then help moving the characters. So this is everything unplugged. And well, we made a lot of tests with students, teachers, and students without disabilities, and we gather all this information to make this a truly universal design resource. So we don't want to say this is for children with disabilities, but it is for all. And it is following the Scratch philosophy, that is following the 5 P's of creative learning, that is learning by playing in a playful way, making projects with peers based on passion and with a purpose. It has low floor, it's easy to start. What was they can create projects from any topic and interest and our subject, and it's high selling because we can make more advanced projects. And it's following the powerful universal learning ideas, diversity of interests, diversity of means of perceptions, and diversity of means of expressions. So we don't have just one way to participate or to express ourselves. We have different options, and this is why each teacher or each student can find new ways of participating. And what can we create with this Scratch Tactile? Let's see some examples. Well, we say it is for all ages as well, because the college students can invent new designs or personalize the designs that are all open. In 2D or 3D, you can find all the designs of the blocks, the boards, and the characters, and they are very easy to manipulate, to edit, and to print, and to personalize. And we foster that anyone that is creating new designs can share with us in the platform that we have opened recently, and you can share with all the world your creations. So, for example, any support or any adaptation you need, we can make it together and then share, because everyone can print in 3D or other ways. And for example, here this student in Harvard invented these giant blocks using foam, and it was great because some children can, some elementary children like these giant blocks. And for example, others invented stories like this about the cooker cat that is that needs to take all the ingredients to make a hamburger. Or for example, Valerie from Cornell Tech in New York, they live in an island and they want to make an activity in the library, and they want to make the board like the island. So they can adapt the board and make with the shape of the island and with the story of a mouse and a cheese that is typical from there. And secondary high school students can as well design prints and then donate to other students from elementary or from special education or others. And they can make new designs to adapt to their interests and then print. And teachers and students can as well add add-ons like extensions. For example, with the camera, we can add QR codes and scan them, or scan with AI the icons and make them with voiceover, with voice speaking. And then, for example, using a microbit and a conductive foil, we can add sounds to the board. For example, we put the conductive foil in the bottom of the character, and when the character is in a square, it detects it and can make sounds or can count like a variable to add points, for example, or invent new extensions. And for elementary, in K6, they can invent stories. For example, this linked with the global goals from the UN about cleaning the oceans, or this is about the games, taking the coins, or we can make a story with reading a storybook like the Planet of Fire that we have in our site. It's about non-violence, and while they are reading the story, they are creating the characters, creating the backgrounds, and coding them. So they are learning literacy and coding at the same time. No, we think it's important that all of us start coding when we are young, because it's said that the things you play while you are a kid can be later your vocation, no, your interest. And even it's a first approach to computational thinking, it can make the difference to the children. And for example, they can invent even new blocks that we cannot invent in the screen. We made these blank blocks, or that you can use and add an icon on the top, or with Play-Doh or other means, or foam, and invent a new action. For example, jumping or singing, or for example, in this case, is collecting the plastic. and well, this is we made these structures that children can use to create new characters at the moment using Play-Doh. Even we can make it in paper, but we think that in Play-Doh they are more tangible, or using this well, other type of Play-Doh that are solids, and so the characters are still tangible, better than if they are in 3D to understand them. So, well, and you can see here other options of projects that children like, because children like children in special education like a lot certain topics. And for example, this was Peter that loved parking cars, for example, and we invent, okay, if you like the cars and the parking, so we can invent parking cars activity. You need to park the car without crashing with others. Or these ones about films or series that they love. And they were, at the moment, instantly, they were engaged in the activity. Or we can quote longer stories, for example, in a library, reading a book. No, this is a very long story with changing the scene. These blocks, these red ones with the white square are blocked to change the background. So we are changing the scene and they are continuing the story in another place. Or we can create any type of project about the space or any topic. This is an example, for example, in New York City, in public school, these teachers receive a 6-year-old student, Elizabeth, that was blind to the last September. And they had 3D printers and wanted to make something for her, and they decided to make Scratch Tactile, and it was a very amazing way to include her and to empathize with her. They made empathy activities with all the students, and then they code with the blocks. The 5th grade students were like big brothers for her and for the 1st grade, and it was very, very nice this experience for them. And later it inspires them to make these Braille blocks to help Elizabeth learn Braille, and all of them can learn Braille. And for example, all the students can invent ways of recognizing the blocks, more advanced applications. And for example, these are pedagogical recommendations in general. We can start with empathy activities, for example, that all the students close their eyes or use some application that can blur your view or some type of this, or we can all well, simulate other type of disabilities so they can empathize with them and make a good climate in the classroom. And because all the children will be the designers of the future, and we want that they are aware of the need of the universal design and of the need of designing for all. No, they will be the future coders, the future designers, inventors, and policymakers, and so they need to know all this since the beginning. So a very important part of this project is the awareness. And then we can make some activity within the big group, in a circle, for example, in the floor. If they can touch or see the floor, they can use their body to code one children or another children. They act like a robot or like a character in the story, and then make an activity with a Scratch Tactile in groups of 3 to 5 students, so they can invent a challenge. One can invent a challenge or imagine a story. Another can create the characters, the backgrounds. And later they can code it, and another one can execute and debug. So it's more a collaborative way of learning. Then they can share with all the classroom, for example. We don't have one way to apply in the classroom. We have any option of depends on you, depends on the teacher, depends on the moment, and so we love to hear from new ways of using and adapting in your reality. And well, and about this project, it has impact more than 10,000 students and more than 1,000 educators and more than 1,000 experiences in the classroom. We have donated at the moment 350 kits, and we have news that I'm sharing with you right now. And in the website, you can find 6 starting activities, 3 lesson plans, and projects from the community, and some virtual books to help you introduce these concepts of computational thinking, unplugged, different activities that can be complementing Sketch Tactile or helping in the explanations or in the activities. As well, as I said, this project is more than a resource, it's a movement for equity. It's a tangible resource, it's a global community, and it's a sensitization project. This is why we make trainings, donations, and accessibility guides for teachers that we created and upload you can find in the website. Thanks for sharing. And then we add an accessibility plugin as well in our website. And we have users from 77 countries that we are amazed because of this big interest, and more than 1,300 users now. And you can find in the website fabrication guides. Everything is explained in detail how to make it in 3D or laser cut, and an accessibility guide and a makerspace map and links where you can find where you can create. If you have, as you said, in your school, you can find in your school 3D printing. It's great, but as well there are libraries near you or other places. Here you can find different directories of makerspaces where you can ask for help to make it. And we uploaded 20 new characters, as you can see, some animals or buildings or flowers or natural objects that you can simply edit. If you want to change them, you can simply edit, change the size, change everything, and you can print. We love this printing in color, but if not, you can just print and then maybe paint. And you can find 20 new backgrounds of different topics in the site as well, from different type of activities. And we promote as well using textures, so children can make the backgrounds tactile. So they can add textures to the backgrounds to make them fully accessible and tangible. And well, we are so happy as well for this translation to different language. We have now English, Spanish, Catalan, German, Polish. Romanian, it's maybe next week, and we have Greek, and we have in the way Portuguese and Hungarian. And thanks to volunteers that are helping with this amazing collaboration. And well, we have a new that is new, and we want to share with you. We are working in a way, as you have seen, this is a full unplugged project. So you code, you move the characters, you talk, it's more collaborative, and we love this way. But as well, we are thinking on ways to connect with the device. And so next year we will deliver this option that you can see. We put QR codes or Aruco codes in the blocks, and we can scan them with a camera, for example, this table camera or even a smartphone, and we can then code as robots. And you can see this, we were testing. And you can see this example. And what type of robot? Well, we can code any robot that uses Bluetooth and it's open. Like for example, a robot with microbits like McQueen or QtBot, or a Scornabot that is an open source robot. So we will make it compatible with different robots. And of course, if you have a specific need, write us and we will try to connect with a new robot. Because this way you can code in the table or in the floor with these tangible blocks and then move a robots. And we think it's a very great feature. And we are very happy because we are receiving recently a grant from Google, and that is helping the project to grow, to create new resources that are coming next year, new resources for teachers, for learning in the classroom and teaching and learning, and improving everything based on research, because it includes a research with, we are searching for a college in the US, and we have a college in Barcelona, Spain, that we want to collaborate together to make this common research in the US and in Spain and maybe in other countries in the future. And we are developing an icon-based accessible coding app. This is a new thing that we are we will be working in this next years, because we think that icon coding it's great, it's simple for little children and for children with different disabilities, but we want to make it more accessible in different ways. And we will be working in this, and it will be open source and open and free to use, of course. And you will find in the website during the next year we will be developing. And this new resource about microbit, making microbit more accessible as well, we will be sharing next year as well. Well, we are open to collaborate for donating kits. We are not selling the kits because it's an open project. We are focused on improving research and making everything open and free. So we are not selling the Scratch Tactile, but collaborating. We love to collaborate with teachers, with organizations, with college, research groups, and creating more resources and making everything more accessible. And we can donate some kits or make some partnership with some organizations, public organizations, to make some donations to schools, for example, with grants or with this type of financial help. So happy to hear from you. And well, all children can learn, but not in the same way. It's everyone's task to make it possible, and we can make a better world. And we want to make creative coding computing accessible for all. Questions and answers. You can now open the mic or using the chat. And I am thank you, Stephanie, for sharing this. This is a document. Well, the idea is that you can just write here some ideas in each of these columns. So you can share your ideas with everyone, because I think we are a lot. You can use the chat as well, but if you prefer to paste here some ideas, it is great to share. What did you think or feel ideas to keep exploring, or the ideas to develop more, or to new designs, new applications that we love to hear from you, and we can maybe implement or together, or you can implement and share, and we can share your ideas as well. Our ideas how to apply to your context or students, and ideas to collaborate or research. And then I have as well this form where if you are interested in this research, if you are at school, you may, and you are accepted to participate in the research, you may receive kits donated for your school, for your students. And then you just need to collaborate in the research, like with surveys or some interviews or this type of help with the research. And you can receive kits for free. And if you are a college or other type of organization, you can help maybe in the research itself. So if you have interest in this, I have shared with you this form, Google form, where you can share your data so we can contact you later. This project starts in January. So well, you can share ideas. What do you think? I have here as well the website and the starting activities. You can see the components and the starting activities, create a story, exploring with natural objects, drawing by programming or using tangible elements, use the body to act or empathize with blindness, or create a game. These are only like activities to start, very open, so you can adapt or use that like they are. And this is the projects page that is new. And here you can explore and see, you can see all the designs. This in wheelchair, this blind, and you can here just explore projects from the community, from different countries, and new characters, backgrounds, print them, or adaptations. Well, or for example, this project from New York. Well, so this is the project. Happy to hear from you. Any feedback or suggestions, we are happy to know.
Excellent. Are there any questions in the chat?
This is that I was so clear.
Yeah. Well, I think this is a very exciting idea. One thing you said that really caught my interest was that it is a movement for equity. That I think is something that we all need to keep in mind whenever we've walked into a classroom and what is being presented isn't accessible, but could be made so, or could have a bridge like this to make it accessible, to start that conversation with the teacher, with the school, with the district, on more of a systemic change of considering all students in decisions on curriculum.
Yeah. I totally agree. Yeah, I think this is key, to design something from the beginning accessible, like universal design from the beginning, not making fixes or things in well, adaptation is good, but it's better making from the beginning, no? And this is the idea that everything needs to be for all. Yeah, and we can apply this to all the resources and designs and things we can invent, no? So yeah, we think it can even inspire children when they are older, or inspire teachers, inspire designers, or well, other people in the society that wants to make more, that wants to work for the inclusion. And because we all needs to be aware and needs to, you know, if you are not including, you are excluding, no? Because the society goes forward, and we want that all the innovation is for all, and the technology is for all to learn, not to leave anyone behind. Yeah.
Absolutely. Very well said. Thank you so
Mhm.
much. I know it is extremely late where you are. I'm sorry, I said Madrid earlier because I was thinking Madrid time, but yes, Barcelona's
Yeah.
you're about 8.5 hours earlier or later there. So you have stayed up late to share this great resource with us, and I really, really appreciate that. And it looks like in the chat there's definitely some appreciation as well. So again, thank you so much. Was there any other questions people had? Okay, looks like you've got some interest in your form. So that, yeah, excellent.
Yeah, please
Excellent.
feel free. And yeah, finally, just to share, we are making a campaign on the social media for so anyone can record a short video and tag with this "make it accessible" hashtag, and like this example that you I share in the chat, and well, so help to spread this word, or of make it everything accessible. And well, so thank you, Leslie. Thank you, everyone, for inviting us and for listening, and keep in touch.
Yes, you as well. Let us know your next adventure. We are always happy to share resources through the Hive and other means. So please, yeah, keep in touch and have a really good night.
Thank you. Thank you.
Wow. Okay. So now we're just about done. We've got a couple of things to wrap things up. I wanted to quickly share, because Roger did talk about 3D printables and things like that, and we talked about a few other 3D printable opportunities. That where do you get your 3D printables if you don't have access to a printer yourself? My go-to when I was working in the schools was I found a high school that had a computer science program. Chances are they had a 3D printer, and working with the teacher saying, hey, here's a project for your students, often worked out to my advantage. Other places, like Roger had a good resource for finding all the maker spaces. That is huge. There's maker spaces everywhere. They're very happy usually to help you do this. There's one specifically in the Mount Lakes Public Library in New Jersey. Has a maker space, and this is one of their favorite things to do. They also have a Quorum blocks, 3D printable blocks. So you can work out your code with the blocks and then transfer it to the computer. So I'm very much looking forward to this. Work it out with the blocks and then scan it with a camera and it be there. I think that is going to be huge. And of course, there's also other public libraries. So there's more access than ever before to 3D printing. And another really good resource is C3D. So SEE 3D is an organization that will do 3D printing for you if it is for a student who is blind or visually impaired, or any person who's blind or visually impaired. So there's a couple of really fast resources for you. I want to turn this over to Stephanie really fast. She's got a few more resources to round out this symposium before we give you our closing code and say good afternoon. Stephanie?
Wonderful. Roger, was there something else that you wanted to share? I saw you pop back on. I didn't know. All right, I will share my screen now, and we will share the APH Hive. Okay, so one of the things we want to make sure that everybody knows as a part of the Coding Symposium is that we have put resources together for you in several different places. The first place that we want to show you happens to be in the APH Hive. That is aphhive.org. On the homepage, you can go into professional communities. And from professional communities, there is actually, it's the very first link on the page, a view resources for accessible coding link. So when we go into accessible coding, there is a link. The very first thing in our blogs and websites is the link to the 2024 Coding Symposium handouts. All of your handouts and your links and the wonderful information that Roger shared with us today is captured in that folder as well. You also have quite a few resources from the previous years and other resources that we've accumulated to help support your coding journey as you continue to learn. We do have some links from the California School for the Blind computer science curriculum, as well as Python lessons, CS Access for All, training videos on CodeJumper, and much, much more. But at the very top, there is a link to a professional community or a discussion board about accessible coding. So you don't have to stop asking questions today. You can go and ask all of your questions and help answer questions for other people in our accessible coding discussion board. So hopefully you can find all of the resources and the things that you need from today's coding session within the Hive. We also wanted to share with you a resource that we think would be really valuable for transition age students. That is with the Connect Center. And the Connect Center actually has an area that's called Career Connect. And within the area of Career Connect, you have some different things for job seekers, as well as some curriculum that you can walk through with transition age students, or that the transition age students can walk through. All right. So one of the places that we really wanted to show was the stories and interviews. We do have some stories and interviews, both on the Connect Center as well as on our APH YouTube page, that share about people who are visually impaired and in the field of technology. So one of the things that is great in the areas that we have some visually impaired people who are at NASA, and that is shared about here, as well as some other areas. So if you're interested in pursuing a career in the area of computer science or coding, this is a great area to go and look and see what different types of careers there are. All right. Leslie, I think I went too quickly through all those resources. Is there anything you want me to go back to and share more about?
I have to unmute and put my video back on.
That helps just a little bit.
No, that was beautiful. This is not by any means an exhaustive list. We would love to add more to this. If you have some to share, please send them to outreach@aph.org, and we can look at making this resource more robust. We really would love to build a kind of one-stop shop for people to find what they are looking for. A few other quick things. We ran a little early, but that is okay, I think. It's been a long day with a ton of information filling your heads. But what we really would love for people to do is to consider how they can take some of this information back to their classrooms, their students, their homes, and utilize it. One big takeaway is how can we build more in the field of computer science? We have a deficit of people in computer science field, and we have a lot of people who are blind or visually impaired looking for work. So this seems like a good fit to me. If you are at the least bit interested, but feel like maybe this is still a little overwhelming, you don't have to be a computer programmer all day long to be in the field of computer science. I highly recommend looking into some of these profiles from the Connect Center more. If you have just the slightest inclination, look at me. I was a comp lit nerd in my undergraduate. I was a TVI. I am not a coder. I think coding's cool. I would call myself a coding enthusiast. And so I get to do things like this and learn about it and promote it. We need more out there. It is the way the world is going these days. So please consider and really think about if you would be interested in hosting a day of code. We had 5 this last year, which was up from our 2 the year before. So we are just growing and growing and growing that. Please reach out to me as well if that is something you are interested in doing. I have more resources specifically for that. We have tons of other opportunities regarding that. Find out more about what a day of code looks like by joining us on January 22nd. This is going to be our recap of our 5 for this last year. Every school did something a little different. Some were really focused on some physical activities that involved the concepts of coding, because coding is in every day. It's in pretty much everything we do. Digital literacy is something that is right up there with numeracy and literacy. There you have so much to learn and consider. So please join us for that. The registration link, I believe, was just popped into the chat as well. And I think we are just about out of our stuff for today. So we will be closing out now. I think we need to give
Yes, I'm back,
Jeff,
Leslie.
thank you, Jeff.
Yeah, so just like a quick reminder, yes, the registration link for, I don't actually think that's gone out, and maybe in one email, but if you want to register for that January 22nd, which is going to be a recap of, we're trying to capture elements of all the days of code. As Leslie mentioned, there's been quite a bit of variety. This wasn't something that was dictated to the groups. We had the opportunity to share some resources. We've been accumulating things over the course of the 4 years, so we had quite a nice array of lesson plans. The California School for the Blind had kind of spearheaded this initially, and we've really looked at this as a community that keeps growing. So again, I would encourage anyone who's interested in more in coding to check out our Hive professional learning community. We also have the previous years of the Coding Symposium, which are fairly long. I believe some of them have been chaptered, so they're a little easier to access now, but those are available on our APH YouTube playlist. And also we did have opportunity, I think a couple years ago, where we did a series of courses for blind adult programmers. We had quite an outcalling with adults reaching out to APH for entry-level coding. So there was a series that was often, and that is also can be found in the APH YouTube channel. So,
and I believe that was specifically on Python.
Yes, specifically on Python. I know we had a few people mentioning that, so that was timely. So I'll keep getting kicked out. Oh, the link, someone asked to reshare the link to the Day of Code registration. I have that, or if someone else wants to grab it, I think I got it.
And you do not have to be a school for the blind to do a day of code. We happen to have a lot of schools for the blind this year, but there was also just a big group out in West Texas. And I did one the year before, just at the Talking Book and Braille Library. Anybody can host, and it can be for any level. We have more advanced and just beginner exploration, have fun, plant that seed kind of activities.
I will also mention, I saw Chancey was in our room. As Leslie mentioned, we had one of those activities at a library, and I encourage any of you that don't have ready access to 3D printers. A lot of our high school technical programs and things like that do have them available, but you also may want to check in with your local public library services, because many of them have resources. I know here in my area, we have embossers at all of the main libraries that are available. I believe some of them have 3D printing available, so get creative, do a little searching, but there are certainly ways of getting access to those things if they're not readily available through your local district or through your specific agency. So, and if you have any questions, I know they dropped our outreach email. We are always happy to answer any questions. So feel free to reach out and ask us pretty much any question. If we don't have the answer, we'll try to direct you to the right folks. So I'm going to go ahead and pause the recording at this time.